Right now, here we go. The circle unit. First thing to go over. We have spent a lot of time this year going over triangles. All right, going over triangles. And we have always named a triangle based on the letters of the vertices. So this would be triangle ABC, BAC, BCA, a lot of different ways we can name it. Same thing when we did the quadrilateral unit, right? I'd say, all right, hey, this quadrilateral WXYZ, because those were the vertices. Look at your circle though. We don't have any vertices. So how do you name it? All right, if I want to talk about a certain circle, how do I name it? Ready? You name it by its center. By its center. So a little note up top, a circle is named by its center. All right, a circle named by its center. So everyone look at here. Everyone sees the center is point C, so I'm going to call this circle. This is circle C. That's how I name a circle. Since it doesn't have vertices, I got to name it by its center. Notation. I don't use this notation, but the textbook definitely will. So I want you to be familiar with it. They may not write out the word circle. They may do this notation right there. Circle C. I'm not a big fan of that, so I don't use it, but the textbook will. All right, 3 parts of a circle I need you to be aware of starting today. There's more coming up, but definitely today. How about this part right here? I left the term of it blank here to see what we know. A segment, a line segment, starting from the center going to a point on the circle. So one end point's the center, one point's on the circle. We know that one? Radius, yes, that is a radius. So we can fill in that blank there with the word radius. One end point has to be the center. Has to be. See this one right here? That's not a radius. It's got to come from the center. All right? And it can't go just randomly hit. That's not a radius either. The other end has to be on the circle. So one end on the center, one end on the circle. John Corleone. How are you? I do, yep. Absolutely, yep. You got it. Bye-bye. There's our daily phone call, reminding us to bring your AirPods to ISS. All right, so everyone's good what a radius is. All good. All right, now, I extend the radius. I extend the radius. So now the endpoints are on the circle, and it still goes through the center. This part here is called that is a diameter, yes. It's got to go through the center, though. It is not a diameter if it doesn't go through the center. So this bad boy over here, I've left for last. That's not a diameter. I know the endpoints are on the circle, but it's got to go through the center. And quickly, anybody know how these two are related? Diameter is equal to 2 times the radius, right? Double the radius, you get the diameter length. And then I left this third one for last. What if it has nothing to do with the center, but the endpoints are on the circle? Anybody know this one? Chord. Chord. C-H-O-R-D. Not a chord, a chord. All right, that is a chord. Now, can I call a diameter a chord? Yeah, absolutely. It just happens to be a chord that goes through the center. All right, so those are the 3 parts. You probably heard of diameter and radius. Maybe chord was the new one today. All good. All right, let's go on to today's topic. You guys know and probably have talked about the distance around a figure. What's that usually called? The distance around a figure. Here we go. This side plus this side plus this side. What am I finding? Perimeter. All right, well, circles don't have sides. So you can't find the perimeter of a circle. Instead, what you find is the distance around the circle, called the circumference. That's our topic today, how to find the circumference. Again, that is a perimeter of a circle, distance around the circle. We're finding the circumference. That formula is on your formula sheet. You choose what version you want. Whatever you feel comfortable with. There's two versions. In class, I'm going to use circumference equals pi. Woo, pi, look at your calculator, please. Let's make sure we know where that bad boy is so we're not searching for it, trying to find it like Waldo. Pi, right above the 9. Okay, everyone see it? Right above the 9 anytime you need it. All right, it's right there. So circumference equals pi d. That's the one I'm going to be using in class. D for something we've already talked about. Diameter length. So I plug in the diameter length for D. That's the one I'll be using in class. If you prefer the other version, please use it, which is C circumference equals 2 pi r. R for radius length. Both will get you the circumference. You guys just got to make a decision. What are you going to use? And again, don't memorize it. It's on the formula sheet in the back of your packet. All right, here we go. Let's jump right into it. We're going to be finding a lot of circumference here today. Very, very basic one right now. Before you find it, directions. These directions are going to come up a lot. Leave your answer in terms of pi. That means when you circle your answer should have a pi in it. All right, I'm not going to go touch the pi button on the calculator. Your answer should have pi in it. First, I want to know, what's the 16 right there I'm referring to? What is that? What did I give you in the problem? What's that 16 called here? Shar, what's it called? That's the radius. All right, well, I told you guys I'm using this formula in class. Circumference equals pi times the diameter length. So I'm not plugging in 16 for D. But we just said the relationship between the radius and the circumference, or the radius and the diameter. So what do I want to plug in for D? Not 16. I plug in 16 if I use 2 pi r. I don't want to use that. I want to use the diameter. So what's the relationship again? 12. Finley, what do we got to do with that 16? Twice, double it. So my diameter would be 32. Now, I would absolutely accept that as your answer because it's got pi in it in terms of pi. But do we say x4 or 4x in here? 4x, right? That's our English language. So I'm going to leave it as not pi 32, 32 pi. Again, terms of pi, leave the pi in your answer. I am not going to go 32 times pi in my calculator. That, look at this answer is what we consider in terms of pi. You have pi in your answer. Questions on a basic one before we up the level a little bit. All right, let's keep, anybody good? All right, grind away. Next one. I still want to use that circumference formula, but for a different purpose now. Find the diameter now. Here's the circumference, find the diameter, and then we'll find radius after. All right, find the diameter if you know the circumference. So here's my formula I'm going to use with you guys. Pi d. Where's that 106.4 going? Don't just pop it in for d, all right? We're looking for the diameter. Where's that 106.4 going in my formula? 16, Bryson. C, it's the circumference. So I plug it in, 106.4, substitute it in for C, equals pi d. We are solving for the diameter, so you better kick that pi out of there somehow. All right, how's the pi going? How do you getting rid of the pi to the other side here, Tess? There you go, divided by pi. Now here's where I want to go to the calculator, because look, it gave me rounding directions, nearest hundredth. And I'll do it with you here. So we go to our calculator, calculations, 106.4 divided by, we just learned where the pi symbol was. Enter, and now we just got to remember how to round to the nearest hundredth. 38, I won't put anybody on the spot here, 38.87 for the diameter. $33, how about 33? Even better. 33.87. Not done yet. Find the radius. So what do I need to do to go from diameter to radius? Boom, diameter to radius. Shara, back to you. divide by 2. Just a heads up. I'd like you to go back to the unrounded answer to get the most exact answer, right? So don't divide 33.87 by 2. Go back. It's already sitting in your calculator, I hope, if you didn't clear it out. And all you have to do is answer or divide it by 2. And there you go. So please cut the unrounded answer or multiply the unrounded answer, wherever you're going to find the radius length, which would be here. What are we looking at? 16.93. And as quickly talk about units. I don't care if units are on there. You're going to get it correct whether you put them on there or not. All right. There's other things I got to worry about. Questions? Dividing by pi. All right. Talk about the square. There's a vocabulary term up there we have not talked about in quite a long time. Inscribed. Circle J. Well, first, let's talk about this. Circle J. What do you know about point J then? Circle J. When I make a diagram here, what are you going to know about point J based on our discussion at the beginning of class? What do you know about point J there, Lauren? It's the center, right? So when we draw this circle, we better have J in the middle right there in the center. So here's my question to you guys. I know I got this circle J here. All right, right? Circle J, there's the center. And then I also got this square. That's got a side length of 9. The square is inscribed. So where do I put things here? Inscribed. The square is inscribed. So it's either going over here or I'm putting the circle inside there. The square is inscribed. Dylan, where do I put the square? Inside the circle. Not just inside the circle. These 4 vertices have to be touching the circle. So make sure your diagram looks neat. Put it here. Move mine around. Inscribed means the figure is inside. Inside. The square is inside with all vertices touching. All right, good start. Each side of the square is 9. And we know in a square, all sides are equal, so we can put that 9 anywhere. All good so far. What's the circumference? All right, exact circumference. Exact, that's remember a couple problems ago it was in terms of pi? That's another way of me writing, leave your answer in terms of pi when it says exact. Okay, it's not rounded, it's in terms of pi. All right, write your circumference formula down. There you go. What's your circumference formula so we can start somewhere? Look at that formula. What's the only value I need? Diameter. What the heck is the diameter? And you know the circumference. That's the only value I need. And that's going to be the toughest part, though, is finding the diameter. All right, here we go. Don't draw these in. I'm going to draw them in just on my diagram. All right, diameter. All right, I know it goes through the center. All right, there's the diameter. Let's see. Could we find the length of that? Well, I know this piece is how long? 9, right? But then I got this little extra hanging out there. I don't think that's going to work because I can't find the whole thing. I can find that part's 9, so it's a little more than 9, I guess, but I'm not going to guess that. That's not going to work. All right, can I draw in another diameter maybe? All right, how about this one? Let's see, can I find the length of that diameter? Same problem, right? How long is this piece? Also 9, but then I got that extra. Ah, darn it! Is there anybody in here that can actually draw a diameter in this diagram that maybe we can find? Because I'm 0 for 2. Is there a diameter that we could draw in that maybe, based on our geometry, we could find the length of? Because those 2 I just put up there, I'm done. Solely, is there one we could put up? I haven't found yet.
Divide the square in half.
What do you mean divide the square in half? Use some vocab terms maybe here. I think you're getting to it, but I want some more details.
A diagonal.
That, we're done. Draw a diagonal in. Watch, ready? Isn't the diagonal of the square also a radius? Or sorry, diameter. The diagonal of the square is also a diameter of the circle. Everyone see that? All right. Yes, we can, but now I'm getting some of you on board. Some of you are still like, I have no idea how to find that. What's that figure inside again called? It's a square. It's got every darn property in the world, right? Every property. All sides are equal. So I know this bad boy's a 9 up here. And what's the angle measures? All these angles of the square are what? I know we took a unit off to do transformations, but what could I do to find that diagonal? Pythagorean theorem, right? It's a right triangle where I know two sides. A squared plus B squared equals C squared. We're going to have to do Pythagorean theorem to find the diagonal. Where are the 9s going to go? Here we go. Where are the 9s? Now we're cooking. Where are the 9s going to go? Whew. Jared, where are the 9s going to go? A, B, C? A and B, good deal. 9 squared plus 9 squared equals C squared. I got 81 and 81 working with me. I got a $1.62. Take the square root. I'm going through this fast because we've done this a ton this year. All right, I go to my calculator. Let's do the square root of 162. Square root 162. I think we all know which one I probably want to write down. Not this long decimal, right? I want to probably keep the 9 radical too. There's the hypotenuse and the diameter. Right there using Pythagorean theorem. So go back to circumference because that was the value we were missing. Circumference, back up. Circumference equals pi times that diameter we just found using Pythag. 9 radical 2. And you guys know my thoughts about the pi coming first. I'm just going to switch. You guys, if you want to leave it, leave it. I'm switching the order though. 9 radical 2. Just do me a favor. Make sure that pi is outside the radical, right? It doesn't belong to the 2 on the inside of the radical. There it is. You want to put inches with it? Feel free. Whatever floats your boat. Anything there? Is it good? Questions? That's how we had to find the diameter using Pythag. All right, go ahead. Use your graph for number 4. We're all over the place here today. Q's the center. And R is a point on the circle. Find the diameter. Ooh. Find the length of the diameter. Well, let's see. What did I give you here? Q and R, right? What did I give you here? If you want a visual, and you please do not break out any compasses for me. Just want to show you what's happening here. Q's the center, and R is on the circle. All right, so if you just want a quick look at what we're looking at here, let me draw in the actual circle for you. R is on the circle, so I want to make sure it's there. Here you go. Ooh, not there. One more time. Nope. Act like you've done this before. There you go. There's your circle. What's QR then? I know I didn't connect it yet, but when I do, what do I call that right there? QR. What do I call QR when I connect those 2 points? QR is called the 14, Stephanie? Yeah, that's the radius, guys. Here you go. I'm giving you the radius. And if you know the length of the radius, how can I find the length of the diameter, which they're asking me for? So if I know the length of the radius, what do I do for the length of the diameter, Lily? Multiply it by 2. All right, next question. How are you going to find the length of the radius so I can multiply it by 2? How are we going to find the length of this radius? Ooh, 12, Finley? Darn right we are. Here we go. I'll let you guys take over. Distance formula if you don't know it. Here we go. I'm going to do the distance of QR. That'll give me the radius. And then I'll double it to find the diameter. Go right ahead. Should be whole numbers here. Whole numbers. Distance of the radius. What was your length of your radius here, Jared? Do you have it? 5, yep. Distance is 5 of the length is 5, so diameter. I take that radius, double it, and the diameter length should have been 10. Not a bad problem. We just had to notice Q and R. Oh, that was when I connect them, that ends up being the radius. All right, you're on the last one, on your own. Okay, I got a rectangle now inscribed. A rectangle inscribed. What's the circumference in terms of pi? Leave pi in your answer. So again, got to find the diameter some way. Got to figure out a way to find the diameter in this one. How can I find the diameter in that inscribed rectangle? Hopefully found or finding right now using Pythagorean theorem, the diameter is 10, just like we did for the square. Leave it in terms of pi. Don't press the pi button on your calculator. Just leave it right there, 10 pi. If you want to put inches in there, you can. All right, there's our circumference, 10 pi inches. All right, you can do what you want with the rest of the time. Answers are up on Classroom.